Unit 7 deals with what's called electrochemistry. And electrochemistry is based on the idea of what's called an oxidation-reduction reaction. So just as a quick review, remember that some of the reactions that we've talked about this year is we've talked about precipitation reactions, where a solid is formed in the products in the reaction. We've talked about acid-base reactions, specifically like a Bronsted-Lowry acid-base reaction, where a hydrogen ion is lost by the acid and gained by the base. We've talked about combustion reactions, where something burns an oxygen to create, most times, carbon dioxide and water. And again, our last type of reaction we'll talk about are called oxidation-reduction reactions, which we just abbreviate and call redox reactions. So a redox reaction is an oxidation-reduction reaction. So let me just give you an example of one here real quickly. That notice that here in the water molecule, oxidation-reduction reactions deal all with charges, and we're gonna call charges something new here in just a minute. But notice that in water, oxygen has a -2 charge and hydrogen has a +1 charge. Okay, and that's pretty common. But then when they're in their elemental form, they both have charges of 0. So notice that oxygen goes from a charge of -2 to 0, and hydrogen goes from a charge of +1 to 0. So we can see that hydrogen's charge is reducing. It's going from a +1 charge to a 0 charge, and oxygen's charge is actually increasing, going from a -2 to a 0 charge. And what that represents is it represents electrons moving. And that's really what a redox reaction is electrons transferring from one thing to something else. Something is losing electrons, and another thing is gaining electrons. And that's where this term oil rig comes in. The concept of losing an electron is oxidation. So oxidation is losing electrons, and reduction is gaining. Okay, so if you gain electrons, it's being reduced, and if you're losing electrons, it's being oxidized. So back up here with water, hydrogen from its +1 to its 0 charge, think about it in terms of electrons. If it was a +1 and now it's a 0 charge, has it lost electrons or has it gained electrons in order to do that? Okay, and an easy way to think about it is if the charge is reducing, then it's being reduced. So which of those is the charge reducing on? It's hydrogen. Hydrogen was +1 and now it's 0. So we can say that the hydrogen in water is being reduced. Okay, whereas the oxygen is going from a -2 charge to a 0 charge. Its charge is actually gaining, so that it's losing electrons to do that. So that is oxidation. So the real term, even though I said charges up here, hydrogen has a charge of +1, oxygen's -2. The real term for that isn't charge. The real term for that is called the oxidation number. Okay, and that's what happens in a redox reaction is, again, something loses electrons, something else gains electrons. And we know that it loses or gains electrons based on the change in its oxidation number, or what's the other word for oxidation number? Is just charge. Okay, on the AP test, of course, they call it oxidation number, etc. So the oxidation number is the number of electrons that an atom loses or gains when it's involved in a redox reaction. So a real easy way to identify a redox reaction is something losing electrons, is something's charge changing, and is something else's charge increasing. Or oxidation number is, again, oxidation number is nothing more than the charge on the ion. So starting with a neutral atom, if an atom gains electrons, then the oxidation number is negative and the atom has been reduced. Again, notice its oxidation number has been reduced, which is why we call it reduction. If you ever are, I can't remember which one's oxidation, which one's reduction. Remember, if the oxidation number is reducing from the left to the right, that is the reduction process. If it's going down, then it's reduction. If a neutral atom loses electrons, then the oxidation number is positive and the atom has been oxidized. And if something loses electrons, something else has to gain those electrons. You can't have part of a redox reaction. It's either a redox reaction or it's not. So if right away you notice, oh, well, oxygen's oxidation number is changing from one side to the other, then it has to be a redox reaction. Because if oxygen loses electrons, then something else has to gain those electrons. So there's some rules. Now, in the case of a simple ion, the oxidation number of the species is equal to the ionic charge. So like F minus, what's the oxidation number of F minus? Of course, -1. So whatever charge it has, that's the oxidation number it has. So like S2 minus would have an oxidation number of -2, Al3 plus, obviously an oxidation number of +3, etc. So there are some rules about how do we determine the oxidation number. The easy way, remember, if we remember from the periodic table, the easy way is +1, +2, +3, and then -1, -2, -3. That's kind of the basic way. But there are just a few things in terms of making sure that we follow those rules correctly. So, first of all, you always start at the first rule and then apply that rule. And then the second rule, and then the third rule, etc. So, if two rules disagree with each other, then you follow the rule that's above it first. So, anytime an element is by itself, when it's uncombined as a free element, its oxidation number of 0. So, anytime something is in its elemental form, it has an oxidation number of 0. Like we just said earlier, H2 and O2, when they're by themselves, have an oxidation number of 0. Okay, so even S8, a sulfur 8-atom sulfur molecule, has an oxidation number of 0. Okay, when you add up the oxidation numbers, like again with water earlier, I said oxygen's -2. So to get back to 0, hydrogen's +1. This is kind of like what we did with ionic compounds. The sum of the oxidation numbers is equal to 0. So unlike carbon monoxide, oxygen is -2. So if oxygen's -2, to get back to 0, the carbon must be +2. Okay, if it's an ion though, then obviously the oxidation numbers must add up to the charge on the ion. So like on the permanganate ion, MnO4-, oxygen's -2, but there's 4 of them, so that's -8 all total. But since this has a -1 charge, the manganese has to be +7 to get back to -1. Okay, so that means manganese in that case has an oxidation number of +7. So here's some of the other rules we already know. Again, follow these in order. And that's why it's kind of weird. But group 1 is +1, so hydrogen, lithium, sodium, potassium, etc. Group 2 is +2, so lithium, beryllium, magnesium, those ones. Fluorine is always -1. And again, the reason that they put that there is because the fluorine rule comes before the oxygen rule, which means like with OF2, the OF2 molecule, this rule comes first. So fluorine is -1, and therefore oxygen in this case must be +2 to cancel out. Okay, that only happens with fluorine though. Okay, fluorine, and really that's maybe like OF4 or something like that. But really that's the only time that fluorine is going to come before oxygen does. Okay, oxygen has an oxidation number of -2 unless it's a peroxide. So like Na2O versus Na2O2. Anytime you see that O2 at the end, that's usually a good indicator that it's peroxide. And then oxygen really, because there's 2 of them, oxygen really has an oxidation number of -1. Okay, hydrogen is pretty much always +1 unless it's with a metal. Okay, so like NaH, remember that rule comes first. The sodium rule comes first, so that's +1. So hydrogen's -1. So when it's with a non-metal, basically, hydrogen is +1. When it's with a metal, it's -1. And then you've got the -1, the -2, -3 on the right-hand side. So again, follow these above oxidation numbers in order. In the molecule OF4, the fluorine rule comes first. So fluorine has an oxidation number of -1, and therefore oxygen would have an oxidation number of +4. That one example, pretty rare, and I've basically given you the 2 times when that can happen. Typically, on the AP test, you can use the +1, +2, +3, and the -1, -2, -3 But again, not always. And of course, they always try to mess with you there. So in example 1, it says calculate the oxidation number of chromium in K2Cr2O7. So if chromium has a +1 charge, which it does, that means overall it's not -2, sorry, it's +2. Okay, so chromium's +2. Okay, and oxygen is -2, and there's 7 of them, so that's -14. So we put those two together, and that equals -12. So we need to get it back to 0. So if those two together are -12, then the chromium altogether must be +12. But since there's 2 of them, each one of them must have a oxidation number of +6. +6 times 2 is 12, and that gets you back to a total charge equal to 0. Okay, I'm going to go through these ones a little bit quicker. Okay, and if you want to pause it at this point and try these ones out, that would be a great idea. And then you can come back and you can compare your answers with mine. So on example 2, part A, the sulfur in SO3 is going to be +6. Oxygen is -2. There's 3 of them. That's -6. So sulfur has to be +6. Here we see an O2. That leads me to think that's peroxide. And then the potassium's +1 anyway. So that's a case where oxygen is -1. In NH4+, hydrogen is +1, and there's 4 of them. So therefore, the nitrogen must be -3. And then strontium in SRF2, fluorine's -1. There's 2 of them. So strontium has to be +2. And then cobalt in COCl6 3-, chlorine's -1. There's 6 of them, so that's -6. But we only need to get back to -3, so cobalt is +3. Okay, and then our final, we got a couple more here. So if during a reaction the oxidation number of an element increases, so it becomes either less negative or more positive, then the element has been oxidized. And if the oxidation number decreases, so it reduces, so it becomes less positive or more negative, then it's been reduced. Again, an easy way to remember reduction is that the oxidation number is the thing that gets reduced, not the charge. Don't think about the charge, think about the oxidation number. Okay, so in the reaction below, Mn, so here it's -8, so manganese is +7. And then on this side, clearly we can see that manganese is +2. So you can see that the oxidation number of manganese is going from a +7 to a +2. It's being, that value of the oxidation number is reducing, so therefore Mn is being reduced. And iron, as you can see, goes from a +2 to a +3 charge. That one's pretty easy. Okay, that charge is the oxidation number. Notice that I still say charge sometimes. The oxidation number is increasing, therefore iron is being oxidized. Okay, and really the better way to say that is to say that Fe2+ is being oxidized. It's always the reactants that are being oxidized. You could even say that MnO4- is the one that's being reduced, even though it's really the manganese. But many times on the AP test, they'll use the whole compound. They'll say MnO4- is being reduced, even though it's really just the manganese. Okay, a couple more examples here. While investigating the chemical and physical properties of metallic element E, a student conducts an experiment combining E and HBr, which react according to the following equation. In the reaction, is E oxidized or reduced? Justify your answer in terms of oxidation numbers. Well, on this side, E is by itself, so it has an oxidation number of 0. On the right-hand side, bromine is -1, and there's 2 of them, so that's -2, so that means E is +2. Okay, so in the reaction, is E oxidized or reduced? Well, you're going from a 0 charge to a -2 charge. Okay, and to me that looks like it's lost 2 electrons. Okay, and again, oxidation is losing, reduction is gaining. So in this case, E has lost electrons. So is E oxidized or reduced? Answer the question. Oxidized. Okay, and how would you explain that? Simply, you would say, because they tell you, make sure you explain it in terms of what they say. Because E is going from an oxidation number number of 0 to positive 2, which is oxidation. Okay? And that's all you had to say there. Okay, example 5. Which element is oxidized in this reaction? Justify your answer in terms of oxidation numbers. So here oxygen is by itself, so it's 0. Here it's -2, so nitrogen is +2. And then on this side you've got NO2. Now be careful here, because is that peroxide? In this case it's not peroxide. Usually when it's peroxide, it's because it's with or it's one of those elements on the left-hand side of the periodic table. Sodium, lithium, potassium, hydrogen, one of those. But usually when it's with another nonmetal, that's just nitrogen dioxide. So here oxygen is -2, and there's 2 of them, so that means that the nitrogen must be +4. So nitrogen is going from +2 to +4. And this oxygen, is still staying the same, but this oxygen is going from 0 to -2. So which number is being reduced? You're going from a +2 to a +4. Nope, that number's increasing. You're going from a 0 to a -2. Oh, that is reduction. So the O2 is being reduced. Okay, so therefore, which element is being oxidized? Nitrogen. And then again, how would you justify that? Because the oxidation number is going from +2 to +4. And that is that is losing electrons. Okay, last one here. So example 6. A student claims that carbon is oxidized when C2H6O is converted to C2H4O. Do you agree or disagree? So we can try to write a chemical equation, but we don't know what the chemical equation is. Okay, but what you can do is just look at this one and look at this one. So oxygen's -2. Hydrogen is +1. So therefore, there's 6 of them, so that's +6 all total. So we've got a +4 here between the hydrogens and the oxygens. So that means that the carbon has to be -2 to get it back to 0. Okay, over here on C2H4O, again, we've got -2 and we've got +4. So that means we've got +2 all total. So that means the carbon now is only -1. So you're going from -2 to -1. And that oxidation number, that's an increase in the oxidation number. So remember, if the oxidation number is reducing, that's reduction. Here the oxidation number is increasing from -2 to -1. So that is oxidation. So do you agree or disagree? I agree, because the oxidation number of carbon is going from -2 to -1, which represents losing electrons, which is oxidation.